Welcome back. Today, we are staging a high-stakes, high-speed digital bake-off. We're throwing three of the world's most powerful machine learning algorithms into a head-to-head race. The challenge? To see which one can master classifying images faster and more accurately than all the rest.
And really, this whole thing boils down to one big question. Forget about training models for weeks and weeks on end. We're looking for the smartest, most efficient path from just a bunch of images to some real insight. So how do we get world-class accuracy in a fraction of the time?
Well, to answer that, we're not just going to throw more computing power at the problem. No, this race is going to start with a really clever strategy, a way to give all of our contenders a massive head start right from the beginning.
And you can really see the difference here. On the one hand, you have the traditional way. On the left, that's where you feed a model millions of raw pixels and basically ask it to figure everything out from scratch. It's an incredibly difficult, time-consuming task. But today, we're taking the shortcut on the right. We're giving our models a pre-built, meaningful map of the images before they even start.
This right here is our secret weapon, DINOv2 embeddings from Meta AI. Now, think of it like this. Instead of giving our models a blurry photo, we're giving them a precise GPS coordinate that describes the content of each image. This coordinate is actually a list of 1,024 numbers that comes from a giant AI that's already learned from millions of other images. So our contenders aren't seeing messy pixels, they're seeing pure, pre-digested meaning.
So, with that incredible head start, who's actually competing in this race? Let's go ahead and meet our three champion algorithms.
First up, we have XGBoost. This is the heavyweight champion, the absolute powerhouse. It's a legend in data science competitions, famous for its raw strength and its uncanny ability to deliver incredibly accurate results. This is the one to beat.
Next in the ring, we've got LightGBM, and its name tells you everything you need to know. This is the speedster. This model is built for one thing, and that is pure velocity. It's engineered to train at blistering speeds, which makes it a really tough opponent in any race against the clock. And our final contender is CatBoost, the strategist. This is the clever one. It's known for being super robust and reliable, especially when you're dealing with all sorts of tricky data. It's smart, it's steady, and you should not underestimate it. Now, to make this a fair race, you have to have a level playing field, right? So all three contenders were given the exact same settings, the same learning rate, access to the same powerful GPU. This means any difference in performance is going to come down to the algorithm's design, not some kind of hardware advantage. Okay, before we get to the main event, our contenders have to prove themselves. This isn't just a single sprint to the finish line. Oh no. We're talking about a series of rigorous qualifying heats to make sure their performance is consistent and reliable. This whole process, known as five-fold cross-validation, is how we get a score that we can actually trust. You can think of it like 5 separate qualifying races. We take our 50,000 images and split them into 5 groups. The model trains on 4 of the groups, and then we test it on the one it's never seen. And we do this 5 times, so every group gets a turn being the test set. Then we just average those 5 scores, and that gives us a super reliable measure of how good the model really is. So once they've made it through those tough qualifying heats, it is time for the final showdown. This is the championship lap, where each model gets to use every single thing it has learned for one last big performance. And here's how that final lap works. After the heats, each contender gets trained one last time, but now on the entire set of 50,000 images. We're not holding anything back. This gets them into peak condition for the ultimate test, classifying 10,000 brand new images that they have never, ever seen before. All right, the moment of truth. The training is done, the predictions are in. It is time to see the results of our algorithm bake-off. Who actually crossed the finish line first? So first up, let's look back at those qualifying heats. This chart shows the average accuracy for each model during those runs. And wow, look at this. It was an incredibly tight race right from the very beginning. All three contenders were just packed together, performing at a totally elite level. And now, the final results. You've got the average scores from the qualifying heats on the left, and on the right, the final accuracy score on those 10,000 new test images. I mean, just look at how close this is. XGBoost and LightGBM finished in what is basically a dead heat for second place. But if you look very, very closely, you can spot our winner. It's CatBoost, by the absolute slimmest of margins, just 1/100th of a percent. The strategist takes the gold, an absolutely stunning photo finish. What's really remarkable here is just how consistent these models were. For all three of them, their performance back in the qualifying heats was an almost perfect crystal ball for how they do in the final. It tells us our testing method was rock solid, and these results, they're the real deal. But you know what? The individual winner, that's not even the biggest story here. The real headline is that by using that smart shortcut, those DINOv2 embeddings, all three contenders, the powerhouse, the speedster, and the strategist, they all achieved over 98% accuracy. That is a phenomenal result, and it just proves how powerful this approach really is. And that leaves us with this one kind of huge question. If a pretty straightforward method like this can get us state-of-the-art results so efficiently, what other complex challenges out there, in science, in medicine, and industry, the ones we all thought were too hard to solve, are now suddenly within our grasp? That's the really exciting part.